This video is going to show you how to solve systems of inequalities. We're going to deal with linear inequalities. So we want to look to see if all of these are already in y equals format. This is the only one that is not in y equals format. We'll get to that one at the end. What we want to do when we are graphing anything, when we have a coordinate plane, we want to make sure we label our x and y axis. This is our x axis right here. So we're going to put an x on the right hand side. Then we're going to put a y on our y-axis, a y on the top. This lets us know which orientation it should go so it's not turned. Now, as we can see on our equations or inequalities, we can see that we're dealing with smaller numbers. So we want to know how much each of these dots, each of these spots are worth. We're going to count by, I'm going to count by 1. So I'm going to put CB1 to show that all of these spaces are 1. So I can go up to 10. If I want to count by 2, I can go up to 20. I'm going to graph these in two different colors so I can show the two differences. Inequalities are not equations. Inequalities can have multiple solutions. So anything that's, let's say, smaller than 5 is 4, 3, 2, 1, 0, any of the negatives. Those are all smaller than 5. They have multiple solutions. So our solutions for systems of inequalities will also have multiple solutions. We're going to highlight all of our solutions. First thing I'm going to do is determine, so my first inequality I'm going to graph in pink. I'm going to determine if it's going to be a solid or dashed line. So since this is less than or equal to, the equal to part tells me that it's going to be a solid line. Solid. The less than will tell us which way to shade. Less than means we're going to shade below the line because that's smaller. So that means I'm going to shade down. I'm going to shade at the end so we can graph everything nice and easily. On the second one, I'm going to graph in blue. Okay, so this one is greater than or equal to. The equal to part tells us it's solid. Since it's greater than, it means we're actually going to shade up because we're going to shade more than the line. Okay, so we're going to graph the pink one first. This is a line. This is a solid line. I'm going to start at, since y equals mx plus b, the -2. So 0, -2 is our first coordinate. Our slope is -1 over 1, so this is down 1, right 1. This is a negative slope. I'm going to draw as many points as I can, many coordinates, so that I can graph this nice and easily, since I do not have a ruler or a straight edge. So I'm going to keep going. Once you can't go down and right any further, I'm going to go up and left, so that I can make sure I have as many coordinates as possible. Since this is a solid line, I can go ahead and connect all of my coordinates as best as possible. It's a solid line. I do put arrows on the end of them because lines do go on forever. Again, I'm not going to shade just yet so I can graph my other line. This one will start at 0, 2 for the y-intercept, so 0, 2. And our slope is -5, so that's -5 over 1. I'm going to go down 5 and right 1. 1, 2, 3, 4, 5, and right 1. Down 5, 1, 2, 3, 4, 5, and right 1. I cannot go down 5 and right 1 anymore, so I'm going to go up 5, 1, 2, 3, 4, 5, and left 1. I also cannot go any further up and left. So now I'm going to, since this is a solid line, I'm going to connect my coordinates as best as possible since I don't have a ruler or straight edge. I'm going to put arrows at the end of them. And now we can shade them. Now I'm going to show you how to shade it in your calculator at the very end of this video. So right now we're just doing everything by hand. So on the pink one, I'm going to pick any point on the pink line, doesn't matter where it is, and it says to shade down. So I'm going to take my pink point, I'm just going to draw a little line down. This tells us this is the half of the graph. All of this section of the graph is what needs to be shaded. So I'm going to shade all of this half pink, or this section pink, all the way through the line, even if I have to cross over the blue. That's fine. Now I'm going to do the blue. Again, I'm going to take any point on the blue, so let's say it's right here, and it says to shade up, so I'm going to shade up. That tells me that this half of the graph is what needs to be shaded. So I'm going to shade like this on the blue. I like to try and shade one going up and down like the pink, and then one shading left and right like the blue, because I can find the crisscross, because I want to find the solution where the two colors intersect each other. There are 4 sections on this graph. I can see that this section right here is only the pink, so that's not our solution. This one has no color at all, so it's not our solution. This section right here only has blue, so that's not our solution. This last little section, this little tiny one down here, has both pink and blue, and you can see the crisscross of the pink and blue. That's our solution. That's what I'm going to highlight. Now, since these are both solid lines, that helps us a bit more because any point on either of these two lines down here would still be considered a solution. Any point inside the highlighted is considered a solution to this system of inequalities. Let's say 0, 0 is not in that highlight, so that should not work. So if we check that out, 0, 0. So I'm going to plug 0 in for x, so that's negative 0, which is nothing, minus 2 is negative 2. The y was 0, so it says 0 is smaller than or equal to negative 2. That is not true, so therefore 0, 0 is not a solution. But let's say if we picked 4, negative 7. Looks like that would be inside the highlight, so we can check that 4, negative 7. 4, negative 7. So 4 is our x value, so we have negative 4 minus 6. Negative 4 minus 2 is negative 6. It says negative 7 is smaller than or equal to negative 6. That is true, because it is smaller than negative 6. If we try it on here, so 4, negative 7. So 4 is our x, so negative 5 times 4 is 20. Negative 20 plus 2 is negative 18. This says that negative 7 is greater than or equal to negative 18. Yes, that is true. So therefore, 4, negative 7 is in the highlight. It is, in fact, a solution. So that's how you can actually check if you don't have the graph. If you don't have the graph, you can actually check the coordinate by plugging it in and seeing if it actually works. Okay. I'm actually going to go to the right-hand side over here and do number 3. So first I want to make sure I have my x-axis and my y-axis labeled, and then I can see that my numbers are relatively small, so I can say count by 1, CB1. So here I'm going to do my pink and blue, so I'm going to do the first one in pink. And this is less than or equal to, so I know that this is going to be a solid line. It's less than, so that means it's going to shade down. On the blue, it's less than, not equal to, just less than. That means it's going to be a dashed line. And it's less than, so that also means it's going to shade down. So now graphing them, the pink. On the pink, my first coordinate is positive 2. So I'm going to go 0, 2, up to 0, 2. And my slope is 1 over 2. So I'm going to rise 1 and run positive 2. Up 1, right 2, up 1, right 2. I'm going to graph as many coordinates as I can. And then I'm going to go back to the original coordinate. And then instead of going up 1, right 2, I'm going to go down 1, left 2. Go the exact opposite direction. And you can still see that you're forming a line. So if you notice that your coordinates are starting to go in a different way, different location, you know it's not a line. So it is solid, so I'm going to connect all my coordinates, put arrows on them. Again, I'm not going to shade yet. So the blue is, I'm starting at 0, negative 3 for the y-intercept. And my slope is negative 2, so that's negative 2 over 1, so I'm going to go down 2, but right 1. So down 2, right 1. So I can't go any further, so I'm going to go back to my original and go up 2, left 1. Up 2, left 1. As many of these as possible. Up 2, left 1. That's as much as I can go. So since this is a dash line, the way I like to do this is I like to connect every other point so that I can see the dash. If I have a lot of coordinates, I try and do that, and I have quite a few, so I can connect every other coordinate so that I can see the dashes. And I just make sure I do have arrows at the end of them. Now we can go to the shading. So again, I'm going to pick a point on the pink, anywhere on the pink, and it says to shade down, so I'm going to go down. It says that this half of the graph is what's shaded in pink. So I'm going to go up and down with the pink. I just do not go above the pink line. This tells me that this is my shading. Okay. Then I'm going to do the same thing on the blue. So I'm going to pick a point on the blue, and it says to shade down. So point on the blue, I'm just going to shade down. This tells us that this half of the graph is blue. So I'm going to shade this way with the blue. Again, I do this so that I can see any crisscross that there might be. So as you can see, we have only blue here, no color here, only pink here, and this is pink and blue. The pink and blue is our solution set. Again, inequalities have solution sets, which includes multiple different solutions. So I'll highlight this section. And yes, it will continue going down, but we're only going to graph this little section of it. So any coordinate inside of here would be a solution, like negative 10, because it's in the highlighted, definitely is one. But if we were to check, let's say 0, negative 3, it also looks like it's in the highlighted section, but we want to check it because it is on this dashed line. So if we check 0, -3. Okay, so let's check it in the first one. 0, half of 0 is 0, plus 2 is 2. It says -3 is less than or equal to 2. Yes, that is true. -3 is smaller than 2. But on this next one, it says again 0, -3. We're going to have -2 times 0 is 0. 0 minus 3 is -3. It says -3 is smaller than -3. That is not true. -3 is equal to -3. That's why it's on the dashed line. So technically 0, -3 is not in the solution set, even though it looks like it's in the highlighted and it's on the line. But remember, this is a dashed line, so it's not actually including it. So that would be the open circle or the open line. Okay. If we move on down to number 2, again, I'm going to graph my x and y, have my x-axis, my y-axis. Now look at my numbers. These are still relatively small. Even though this is -13, it would be off the graph. I could count by 2s, but I still want to just count by 1s because it's really low off the graph. It's not that far away from the graph, so I can still graph that relatively easily. So again, pink is the first one. This is just greater than, so this will be a dashed line. And it does say greater than, so it will be graphed up, or it will be shading up. On the blue one, it says less than, so this will also be a dashed line. And since it is less than, it will be shading down. So for the pink, I'm going to go to 0, 5, 1, 2, 3, 4, 5. Here's my first coordinate. And then -2 is my slope. So that means down 2, right 1. I'm going to graph as many of those as I can, as always. Down 2, right 1, down 2, right 1. And since I can't go down 2, right 1 anymore, I'm going to make sure that I go up 2 and left 1. Okay, so go back to my original, up 2 and left 1, up 2, left 1. Now this is a dashed line, so again, I'm going to do the same thing I did earlier with graphing or connecting every other coordinate. Since I have multiple coordinates I can do this with. If you only have a few coordinates, it's a little bit harder to try and do that. So just try and dash them as much as possible. So on the second one, I'm going to start down at -13. Now this is off the graph, so this is -10. Let's say this is -11, -12, -13. So this will be my first point. Okay. My slope is 1 over 1, so I go up 1, right 1. So I know this is going to be roughly right here. Up 1, right 1, again roughly right here. Up 1, right 1. So now that we're on the graph, it makes it a little bit easier. So now we can just keep going up 1, right 1. And again, since it's dash, you can do the every other coordinate. Every other coordinate you can graph. So I'm going to have my line. Every other coordinate. And you can actually keep it going here so that you can have the off the grid as well. So now we're going to shade. So again, back to the pink. I'm going to take any point on here. I'm going to shade up. So any point on this pink, I'll just shade up. So this tells us that this half of the graph is shaded. So I'm shading this part right here. Okay. And then we're going to take the blue. I'm going to take any point on the blue, and it says to shade down, so I'm shading down. This tells us that this section of the graph is being shaded. So I want to find where they crisscross. No color, pink, blue, and this is where both of the colors match. So I know I'm going to highlight inside of here. And now since these are both dashed lines, any coordinate that is on these two lines would actually not be a solution. But like -10 is inside this highlighted section, it would be a solution. All right, and this last one, as I said earlier, this is the only one that is not in the y equals format, and as you can see, there is no y. If it's only an x value, this is actually considered a vertical line. This is the only type that you cannot graph in your calculator. This is actually really important. Okay, so I'm going to go ahead and do my x and y, so don't forget that, x and y, and we have smaller numbers, so I'm going to again count by 1, CB1. You have to make sure you do that on all your graphs. Okay, so again, I'm going to draw the first one in pink. This one is still less than or equal to. It is still a solid line. But because it's not a y value, I can't shade up and down. Because it's a vertical lines go like this. There is no shading above or shading below. It's only shading to the left or shading to the right. So since it says less than, everything that's smaller than would go to the left because the negatives go towards the left. So I'm actually going to shade left. These are the only type, x equals are the only type that are vertical lines. So these are the only kind that you can shade left on. Okay. On the blue, this again goes back to the y value. So this is again a diagonal. This is less than, so it's a dashed line. And it's less than, so that means it is again shading down. So for the pink, we're going to the x of -3. That's why we want to know the x-axis. So we go to -3 on the x-axis. And it is a vertical line, so it will just be a vertical line going through here. It's solid, so we can just draw a vertical line down this line. Okay, I'm not going to shade yet again. Okay. I'm going to go to the blue. I'm going to have that +2, 0, 2 is my first coordinate. Our slope is 5/3, so up 5, right 3. 1, 2, 3, 4, 5, 1, 2, 3. Okay. I cannot go up 5 anymore, so I'm going to go down 5. 1, 2, 3, 4, 5. And I'll go left 3 this time. 1, 2, 3. Try and do that again. 1, 2, 3, 4, 5. 1, 2, 3. Since we're able to do that. It is dash line, and this time I only have 4 coordinates, so it would be really hard for me to just do every other coordinate. So I'm going to try my best to just get it dashed along these 4 coordinates. This is how you would do it if you have fewer coordinates. Just make sure you put arrows on the end. Okay. Now we're going to shade. So yes, on the pink, it does say shade left, so this one is literally just shading left from that pink line. Same way we've been doing. Okay. Now on the blue, we're going to shade down. So any point on the blue, it's going to shade down. So this tells us that this half of the graph is shading down. Again, I'm just going to shade this lightly in blue all the way along the blue line. I'm going to find the highlighted section. This is only pink. This is no colors, only blue. And this little section is where they crisscross. So I'm going to highlight this section. Now it looks like -3 might be a solution, but because -3 is on the dash line as well, it would not be a solution. Now, as I said, I did at the end of the video, I wanted to show you how to do this in your calculator. Obviously, I can't show you this one because of the vertical line. You cannot graph it in your calculator. So I'm going to show you this one right here. Okay, so I'm going to take my calculator. I'm going to take my calculator, turn it on. I'm going to go to my y equals. Now I'm going to graph, since these are y equals format, I'm going to type in -2x plus 5. Do you notice that these plots are not highlighted? That's really important to not have those highlighted. My second one, I'm going to have x minus 13. I'm just going to I'm going to press graph real quick just to see the lines. There was the pink line and there was the blue line, so that was right. Now I'm going to show you how to shade it in your calculator. You can have the dash lines and solid lines, however, those are a little generally easier to determine which one is which. It's the shading in the calculator that's a little harder. So if I go back to my y equals symbol, and I come over to the left-hand side, all the way over here where it's blinking. Now some calculators are slightly different, so just kind of follow along with your type of calculator. When this is blinking, if I press enter on it, the first one that pops up, this is like a really solid line. So I can actually go through these. If I press enter multiple times, it changes the way they look. I keep pressing enter, and it will eventually go back to my original. And this is my original. Okay, so I want to show it shading up. Okay, so again, you can only pick one or the other. You can only either shade or you can show the dotted or solid. So I want to show the shading. So I want to shade up. So this first one is a really solid line. That's not going to help me shade. Then press enter again. Now it has like a little shading area. Do you notice that this one is shading up and to the right? That's the way that the arrow is pointing. That's what we want for up. So we want it to shade up. So this is one we want. If I go down to this next one, I want to shade down. So again, if I press enter the first time, it'll just do that really dark line, which is not what we want. Press enter again. Again, it goes up and to the right-hand side. So I press enter again. This one is now pointing down and to the left. That's what we want because it's down. That's what we want. So we have, on here, we have this one shading up and to the right, and this one shading down and to the left. The point is we want the up and the down. So when we press graph, this should show the pink should be shaded over here because we know the lines are correct. and then the blue one should be shaded down here. So this is where it should crisscross on the graph on our calculator. So if we press graph, here comes the pink, and here's the shading like we had earlier, and here comes the blue, it's shaded down here. And you see how this is a little checker down here, it's a little crisscross? It's the same way we have it down here. So that's actually how you shade it in the calculator. Again, you can only pick either the shading or you can pick the dotted versus solid. You can't have them both. So just, again, the shading is probably the harder one to do because the solid and dotted comes from the inequality of equal to or not equal to. Okay?